Hello, this is Michael Hall, and today I will be presenting my IBM Advanced Data Science Capstone project. My project is based on the Yelp Challenge dataset, and utilizing that dataset, I will be predicting the likelihood that a photo contains a pizza item. So let's get started. For the use case, a model is required to predict if a particular food item is present in a photo submitted by a user in the Yelp database. Currently, Yelp is only able to identify if a phrase is included within the photo caption. The challenge dataset provided by Yelp was utilized for this project. Within that dataset, two files were used. One was the business table, which contains information around each of the businesses, which included a unique identifier, the business name, and then additional information around each of the businesses. Also, a photo table was utilized. That table contained a unique identifier for each of the photos, a linkage back to the unique identifier in the business table, as well as any caption information provided with each of the photos. Also, a folder containing all of the JPEG images of all of the photos was used. The solution to this problem required that a model be created to predict if a particular food item was present in a photo. Currently, Yelp is only able to identify if a phrase is included within the photo caption, not that the food item is contained within the photo itself. A total of 5 models were evaluated, 2 using logistical regression and 3 using convolutional neural networks. The final model utilized was a convolutional neural network, which included data standardization and 7 layers. The test accuracy was 81% for the validation dataset. The solution was built utilizing a Python application built in a Jupyter notebook. A lookup database was created by joining the photo and business tables. The caption from the photo table, in addition to the categories and names from the business table, were then concatenated into a single column and then were all converted to lowercase to facilitate searching. In addition, any missing data was dropped from the database. The convolutional neural network was built utilizing the photo captions that would identify the target item, in this case pizza. Then the photo was utilized to then predict if a food type was present for the photos queried by the user utilizing the model. Here is the application in action. In this particular case, the user entered in Chicago style. That search term was then looked up within the database to identify any photos that had matching information that also contained the search term. In this case, we returned 9 photos. Of those photos, we then put each of the photos through the prediction model to determine the likelihood that that photo then contained pizza. As you can see, in the case of, it did a fairly good job of identifying those cases. However, in one situation, it predicted that a tray of sandwiches was in fact a pizza. So you can see it was not 100% accurate. In the next example, we used a search term NY style. The resulting photos were then run through the prediction engine. Once run through, we can see that in those instances where pizza was included in the photo, it did a very good job of identifying those. However, it also included one additional situation where it included a piece of cheesecake in the shape of a pizza as predicting that it was also pizza. But overall, it did a very good job of predicting whether or not a photo did in fact contain a pizza item. For the architectural choices, Anaconda was used as the platform. Jupyter Notebooks with Python was utilized for the actual development. Pandas was utilized for file processing, and Matplotlib was utilized for processing images and displaying. In addition, for feature creation, NumPy was utilized for array creation. In addition, sklearn was utilized for logistical regression. TensorFlow and Keras were utilized for the convolutional neural networks. The application itself was built utilizing Anaconda and then Python and Jupyter notebooks. In addition, Pandas was utilized to process the JSON files. Keras and TensorFlow were then utilized to implement the actual resulting model. The considerations that went into choosing these were the dataset size, which was not very large, the number of photos, which was not very large, as well as the flexibility provided by having a local workstation to do the development. For pre-processing, the photo table was loaded, and then caption column was transformed to lowercase to help standardize the search. In addition, rows containing pizza were then separated out into a new data frame that will be used as the true data set, and then a separate data frame was created for any rows that did not contain pizza for the false data set. The resulting data frames were then utilized to copy the matching photos into their own individual folders. A total of 2,328 pizza images were then copied into one folder, and then a similar number of 2,328 random photos not containing pizza were copied to their own folder. The resulting images were then evaluated to determine the height and width of the photos, to determine then the feature selection. In this particular case, I was able to identify that using 100 by 100 for the height and width was the appropriate amount to utilize to minimize the loss of data. So for feature creation, we resized the images to 100 by 100 by 3, and then added image augmentation to increase the number of samples, since we only had 2,328 actual pizza images to work with. 5 models were ultimately built, 2 with logistical regression, 1 with standardization, 1 without, and 3 convolutional neural networks, 1 with standardization, 1 without standardization, and 1 with standardization and additional layers. The resulting models were then evaluated based on accuracy score. The 2 logistical regression models, the first one came in at 67%, and the second one came in at 72%, so a slight increase once we added in standardization. The convolutional neural network without any standardization performed horribly at only 50%. By adding standardization, it increased up to 76%, and then by adding in an additional layers, it increased all the way to 81%. This was ultimately the model we used for implementation. Here's the actual description of the model that was ultimately utilized. There was 2 convolutional 2D layers. In addition, max pooling was used for both of those layers. In addition, there was a flattening layer, as well as a dense layer, and then the final sigmoid layer. I was very happy with the results. Given the fact that we were using caption information and not actual photos that had been manually reviewed to determine whether or not pizzas were included in those photos, the overall performance was much better than expected. Going in future, I would suggest utilizing manual review of those images to make sure that all of the photos that were included in the true data set actually included pizzas would have been could have even gotten much better performance. But overall, by just utilizing just the caption information alone, it was performed much better than what you would have expected. I hope you enjoyed this presentation.